Hello, welcome. Today we are going to be looking at particle size, mass, and quantity. Over the years, scientists have been trying to find out the size of molecules or atoms, though it is not yet still possible to, with the help of the eye, to see the size of the molecule. We know that the size of molecules or atoms are in the range of n times 10 to the power minus 7 cm, where n is actually between 0 and 10. So that is the size of molecule between n times 10 to the power minus 7 cm in the range of, where n is in the range of 0 and 10. Now we are going to be looking at relative atomic mass and relative molecular mass. Relative atomic mass, also known as mass number, is a quantity that we are going to be using in doing several calculations in chemistry. Also, relative molecular mass, very, very important. We're also going to be using it to do lots of calculations in chemistry. Now, relative atomic mass is for elements or single elements or elements that we can easily look at on their own, whereas that of relative molecular mass is for compounds. So let's say relative atomic mass for element hydrogen, the mass number or the relative atomic mass is 1.008, whereas that of oxygen is 15.99, approximately 16. Now, what do we understand in this relative atomic mass? When we check the mass number, or when we check the atomic number of hydrogen, it is 1. When we check the atomic number of oxygen, it is 8. So 8 times 2 will give us the mass number, or the relative atomic mass. So mostly we are going to find out that the relative atomic masses of the elements are actually 2 times their atomic number. Take note, because the atomic mass is actually consisting of both the neutron and proton inside the nucleus. And you know that the proton has the same mass as the electron. And the electron number is actually, the mass there is actually giving us a perspective of what the relative atomic mass is. So when you add up both the mass of the proton and the neutron, you have the atomic mass. So it's actually like 2 times the atomic number. So that is what the atomic mass is, 2 times the atomic number. Roughly, not accurately, but approximately 2 times the atomic number. So if you check the last lecture where I gave the atomic numbers of the elements, so each of them, when you get to the atomic number, just do times 2 of it. It's likely that you get the mass number or the relative atomic mass. Another word for the relative atomic mass is actually mass number. So you can be seeing them interchangeably used. Now, instead of doing 2 times the atomic number to get the rough estimate of what the mass number or the relative atomic mass is, the equipment that is used to find the relative atomic mass or the relative atomic number is what we call mass spectrometer. Very, very important, mass spectrometer. So with this mass spectrometer, you can actually measure the relative atomic mass and get the actual number. And that's why you're able to get this. So this I actually got from mass spectrometer. And why we have them in fractions is that most atoms actually have isotopes. So they have isotopic forms, 2 different forms existing with the same atomic number for but different molecular mass or different atomic masses. So because of that existence, we have this. And previously, the reference point for checking the relative molecular mass, it was actually hydrogen, because hydrogen has that of 1. So the ones that have, because hydrogen is the lightest element, so every other element has mass that is heavier than hydrogen. So they were all calibrated with hydrogen as the reference point. But in modern time, that we are now using mass spectrometer and observing the fact that there are isotopes, we are now using carbon as the reference point. So with those two into consideration, you can say that the relative atomic mass, AR, relative, R stands for relative, A is atomic mass, of an element is the number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon-12. So the relative atomic mass for hydrogen is 1.008, that of oxygen is 15.99. So you can easily say that the mass number of oxygen is actually 16. Now, the relative molecular mass, when you're talking about molecular mass, talking about compounds. The relative molecular mass of an element or a compound is the number of times the average mass of one molecule of it is heavier than 1/12 of mass of one atom of carbon-12. So this carbon-12 is actually the isotope of carbon that is used as the reference in these calculations and using mass spectrometer to measure. So for relative molecular mass for, say, compound, calcium triazocarbonate. So if you want to calculate this now, you have Ca. The relative atomic mass for calcium is 40. So there is only one calcium, only one molecule, so you have 1 times 40. Carbon, the relative atomic mass for carbon is 12. You know the mass, the atomic number of carbon is 6. So the relative atomic mass is times 2, which is 12. But since there is only one carbon atom, we have 1 times 12. Then the relative atomic mass of oxygen is 16. As we have here, 15.99, approximately 16. But there are 3 atoms of oxygen, we have times 3. So when you multiply out and add up together, you have the relative molecular mass of calcium triazocarbonate to be 100. So that is how you do this calculation. Very, very simple. So you use this 100 in your calculation. So calcium carbonate, the relative atomic molecular mass is actually 100. So that's how you calculate relative molecular mass. You add up the individual elements that are involved for a compound. Whereas relative atomic mass, just write straight down the reading from the mass spectrometer. So these two very quantities, we are going to be using it a lot in calculating. Note, you can also hear this, some people call this relative atomic mass, mass number. This also mass number, but in specific terms is actually the relative atomic mass, and this one relative molecular mass. Thank you. Please, if you enjoyed this video, hit the subscribe button. Support us in any way that you can. Thank you. God bless you.